Ever wondered how we calculate the heights and distances of far-off objects without actually measuring them? It's all possible with the magic of trigonometry. But what is trigonometry, you might ask? Well, in the simplest terms, it's a branch of mathematics that studies the relationships between the angles and sides of triangles. Picture a triangle in your mind. Any triangle, it doesn't matter. Now imagine knowing the length of one side and the measure of one angle. Trigonometry allows you to figure out the lengths of the other sides just with that information. And it's not just about triangles. Trigonometry has wide-ranging applications in various fields. Physicists use it to understand the laws of nature. Engineers apply it to design and construct buildings and bridges. And even game developers use it to create realistic movements and animations in video games. Now that we know what trigonometry is, let's dive into its applications that we come across in our daily life. Imagine standing at the base of a tall building and trying to figure out its height. Or being on a ship and calculating the distance to the shore. Sounds difficult? Not with trigonometry. This branch of mathematics is all about studying the relationship between the angles and lengths of triangles. Now, how does this help us in real life, you may wonder? Well, trigonometry is a powerful tool used in various fields. In construction, for example, it helps architects and engineers design and build structures by calculating angles and distances. In navigation, sailors and pilots use trigonometry to chart their course and determine their position. Even in the field of astronomy, trigonometry is used to calculate the distance of stars and planets from Earth. Isn't it fascinating how trigonometry helps us in so many ways? But how exactly does it do that? Let's find out. Trigonometry forms the backbone of height and distance calculations. But how does it work? Let's unravel the mystery. To start, let's break down the concept of trigonometric ratios, sine, cosine, and tangent, and how they are used in calculating heights and distances. At the heart of trigonometry lies the right-angled triangle, a triangle with one angle measuring exactly 90 degrees. This triangle is very special because the ratios of the lengths of its sides remain constant, no matter the size of the triangle. These ratios are what we call the trigonometric ratios. The sine ratio, often abbreviated to sin, is the ratio of the length of the side opposite the angle to the length of the hypotenuse. The cosine ratio, or cos, is the ratio of the length of the adjacent side to the length of the hypotenuse. And the tangent ratio, or tan, is simply the ratio of the sine to the cosine, or in other words, the ratio of the opposite side to the adjacent side. Now, how do we use these ratios to calculate heights and distances? Imagine a scenario where you're standing a certain distance away from a tall building. You can measure the angle of elevation from your eye level to the top of the building using a clinometer. Now, you have a right-angled triangle formed by you, the building, and the line of sight. Here's where trigonometry comes into play. Let's say you know your distance to the building and the angle of elevation, and you want to find out the height of the building. You can use the tangent ratio. Remember, tan is the ratio of the opposite side, the building's height, to the adjacent side, your distance to the building. So the building's height is just the tangent of the angle of elevation times your distance to the building. With this understanding of how trigonometry works, you can now solve problems related to heights and distances. Ready for some practice? Now that we've understood the concept, it's time to put our knowledge to test. Let's dive into some practice questions. Imagine you're standing at the foot of a tower and the angle of elevation to the top of the tower is 60 degrees. If you're standing 20 meters away from the tower, how tall is the tower? To solve this, we'll use the tangent of the angle, which is equal to the height of the tower divided by the distance from the tower. Here's another one. You're flying a kite and the string makes an angle of 30 degrees with the ground. If the length of the string is 50 meters, how high is the kite above the ground? Again, we'll use the tangent of the angle, but this time it's equal to the height of the kite divided by the length of the string. Remember, practice is the key to mastering any concept. Keep practicing and you'll get the hang of it in no time.